Pilot 11, Asset Management, and live on the stage again here in Best in the Netherlands is Alexander Furnica, a data scientist in the Hospital Services and Informatics Department at Philips Research, and Job Gutteling, a clinical physicist at OLVG Hospital in Amsterdam. Gentlemen, the video will start first and then we'll hear from you.
Here at OLVG, we like to look ahead. We know how technology can support and improve our care processes. That's why we're always looking for new applications, like the Realtime location system. This system helps us to locate our medical equipment and devices, allowing us to deploy them more efficiently. Nurses can spend up to 30 minutes of their shifts looking for medical equipment or devices. During this time, the equipment is not being used. And sometimes a device will never be found. We think this is a waste. That's why we use RTLS. Using location identification, this system can accurately localize and track equipment and devices, whether it's at a patient's bedside or on a shelf in the storeroom. All of the equipment and devices are fitted with tags, which send a location code to the RTLS system via Wi-Fi, Bluetooth, or infrared. Imagine, Tracy, a nurse on the surgical ward, is looking for an infusion pump. Instead of hunting around herself, she can consult the RTLS system online. The system immediately shows Tracy where she can find an infusion pump. She can also see per room what equipment is located there. She can work more efficiently as she knows where everything is, and this saves time. In addition, RTLS gathers data to analyze whether all of the equipment and devices are being put to good use. This has several benefits. We can improve our workflow, cut our costs, and raise our clinical quality. In future, we can also use RTLS to protect vulnerable patients, for example, or to mark out more efficient routes for inpatients visiting different examination rooms, all to enable us to spend more time on patient care.
Yes, so that was a nice video, and to quickly summarize the video, these were the objectives of our pilot. So on the first hand, we wanted to improve the utilization rate of our mobile assets to save cost. We also wanted to improve the search time, so actually lower the search time to increase productivity of our staff and to increase the staff satisfaction at the same time. So as you saw in the video, there are several relevant factors to this pilot. One of them is cost, but more importantly, of course, the clinical aspect of it that you saw in the video. So the pilot actually consisted of three parts. First, there was a baseline part, which included an analysis of the current situation. So what we did was we asked questions to our staff using questionnaires, standardized questionnaires that we repeatedly send out. And we introduced the so-called RTLS stopwatch. You saw the badge already before, so it's like it was designed originally for nurse call uses, but we actually transformed it into basically a stopwatch that you could push one button to start the clock, and if you're looking for an asset, if you found the asset, you could push the next button and then you would finish the time, and we would record this time and actually measure what was going on. So then we did our intervention, which included an asset finder tool, which looks like this and which you can see also in our booth presentation later in the day. So we introduced this software into the clinical practice and asked people to use the software. And then in the end, we also did a post-intervention follow-up where we again asked questions using the standard questionnaires, the same questions from the beginning. We again used the RTLS stopwatch to measure the search times. And we also employed data analytics from a system using the data that we gathered with the RTLS stopwatch. So now I'm giving the word to Alex.
Thanks a lot, Job. So I'd like to talk to you a bit about the technology that we used. Of course, you've already heard quite a bit about RTLS as a system, so I won't repeat everything again. I'd like to focus instead on what we did different in Pilot 11, which is two things. Basically, we had a front-end application that staff could use in order to check the location of the assets in real time. This would help them search for these assets and address the search time KPI that Job mentioned earlier. Additionally, what I'd like to spend more time talking about today is the Wi-Fi infrastructure that we had. Wi-Fi is essential really to our pilot in this case because it helps us have enterprise-wide tracking. When I say enterprise, I mean through the entire hospital. Why Wi-Fi is useful in this case is because using infrared in an entire hospital can be a very costly solution, although very accurate, whereas Wi-Fi can already leverage the existing infrastructure that a hospital already has. So we made use of that in this pilot. The disadvantage of Wi-Fi, though, is that you have quite rough location estimates. In OLVG, we've seen error radiuses of up to 10 meters, and of course, being a radius, that can be in any direction. So you can imagine when searching, that already introduces some difficulty, but when performing analytics, drawing any sort of meaningful conclusions becomes a lot more difficult with such an error margin. So what do we do to address that? Well, we of course looked at infrared as well, and utilization is important to know actually first how we define utilization. And the way we define utilization is basically time outside of storage. Our logic is that we know for sure that when an asset is in storage, it's not being used. And therefore, we can conclude that time outside of storage is a pretty good proxy, approximation of utilization. For infrared, this is pretty straightforward. Of course, we can trust its accuracy. So we know for sure that when an asset reports being in storage, it is in storage. We can count the amount of time it's spent in storage and therefore draw an approximation of utilization that we can trust. Things change, though, when we look at Wi-Fi. Due to its inaccuracy, of course, that becomes more difficult. So we started by understanding what does that exactly mean? What does this inaccuracy mean? By performing a number of experiments where we left some tags sitting for at least 24 hours motionless within storage rooms in OLVG Hospital, OLVG West to be precise. After collecting 24 hours of data, we would use this, what we call fingerprint, and we call it a fingerprint because we would hope that 24 hours of data collected by multiple tags from the same room would provide enough of a unique pattern to characterize the storage and that we could use. You can see in the image on the slide, the yellow rectangle is the storage room. The yellow dots within the storage room are the tags that we placed there, motionless, mind you, for 24 hours. And all the green and red dots are all the location reports from these motionless tags. So you see already how large the spread can be. So what do we do with these fingerprints afterwards? Well, we average them out into a single point we call a centroid. You can think of this as the sort of digital center of the room as opposed to the real life center of the room. And you can see in the image on the slide how different those two can be sometimes. The way we leverage then these centroids to actually improve our utilization algorithms is whenever we would get a Wi-Fi report from the RTLS system, we would check if it falls within a radius of these centroids and assign them to the storage room if that was the case. This radius is a user-selected parameter that could be experimented with in the future to perhaps automate, customize per room, and improve even further. So those were our methods, but what did we manage to conclude using these methods? Well, let's start on a department level utilization. This is in the Mother and Child Care Department of OLVG, and in here we managed to leverage infrared infrastructure completely for one department. So again, the same rule applies here. Assets in storage are not in use. Assets outside of storage are in use. We see here we had a total of 54 assets, 12 different asset categories, and this is data spanning 6 months. We see that utilization varied from down to 1%, almost no utilization at all, up to 41%. So there's still a lot of room to go till 100%. From there, we managed to conclude then that we can reduce the inventory of assets for the Mother and Child Care Department, 16 assets in total in this case, averaging around 93,000 euros, already 30% of the cost of all these assets that we tracked in this particular case. What happens though if we zoom out to the hospital level? Well, like I mentioned earlier, when we look at a hospital level, here's where we have to start looking at Wi-Fi and things get a little more complicated. However, even in this case, we've managed to show that a reduction of assets is possible. We see here on the slide a particularly important asset class due to how large the population is, volumetric pumps. We managed to show a reduction of around 16 pumps using Wi-Fi throughout the whole hospital. that totals to around 23,000 euros. And we estimate that if we had had infrared everywhere and we had a lot more confidence in the reports that we were receiving, we could even reduce up to 76 pumps. That could reach a total of 110,000. You can see a little bit more detail on this slide in this graph. The red line that you see in the graph is the maximum Wi-Fi utilization that we've noticed. Above that is a 5% buffer that we introduced because we wouldn't want to reduce the stock more than necessary. Of course, our patients are our priority, so we want to make sure we don't cut the inventory so much that some patients would be left without the devices that they need. The gap that's left in the graph on top of that are the savings then that we can find. Further below in the graph, you see a green line. That's the infrared estimation that we talked about. But I'd like instead to spend a little time on the gray line, which is the ground truth. So you can imagine, I also call it a utilization proxy because we overestimate utilization on purpose, so we don't cut the inventory too much. And so that means that actually utilization is still a bit higher, still a bit lower than probably is estimated. So we could perhaps reduce stock even further. Ideally, though, we would look for some middle ground because infrared, again, is very costly to implement and Wi-Fi could perhaps be further improved. So some potential things to look at in the future would be more advanced algorithms, maybe expanding infrared only to storages, or even using an IoT platform to leverage other smart assets in the hospital, essentially give more context to the asset in question. So, there it is. So otherwise, we've also developed a asset utilization reporting tool. Now this tool automatically collects, processes, analyzes the data, and creates an interactive report that is sent to the interested parties. It is an HTML report with interactive graphs that users can then filter and inspect themselves. You see some examples here, a utilization graph in the left of the slide, a heat map showing the total population of assets spread across floors, across time, to help you understand how the stock changes in the building, as well as a network graph that could perhaps be complementary to the stock because it shows transitions between floors as opposed to stock. So in a hypothetical scenario, for example, this could show whether the storage placement for a particular asset category is optimal or could be improved. And now back to you, Job.
Yes, thank you. Yeah, as you can see, we also investigated the staff satisfaction. So at the beginning of the pilot, we measured on a 5-point Likert scale, as I mentioned, using the questionnaires. And it turns out that the people were not really happy to start with. And of course, it's not really clear if that was all about the things that we were investigating. But what we did see was that post-intervention, with 2 measurements, and staff satisfaction increased from a 4.9 on a scale of 1 to 10 to a 6.3, which is a significant improvement. But of course, still a long way to go until we have really happy clients or actually hospital staff in this particular department. And this is a very interesting and important topic that was also discussed previously in pilot number 9. Because moving on to the conclusions, one of the things that we did see, and I'm skipping to the second part here of this slide, what you can see is that we found out that there were lots of changes going on in the department where there was a real shortage of staff, so they had to close down different sections. At one point, they even closed down 1/3 of the department, which means that a significant portion of our whole measurement system was basically not doing anything. So you have to realize that if you are creating a system like this with a significant infrastructure, that you also are quick to adapt to changes in the hospital environment. Because once you start with your measurement, and this project took 3 years, when we started it, the department was really eager to come with us and to work with us to improve the situation. As you could see before, they were not happy, so they wanted to be in a better position, but other things changed as well, and you really have to take this into account. But one step back, we see that the data from the RTLS system provided us with a lot of new insights, and we were able to use those insights to improve utilization and basically realize effective cost reduction only on this department level. But if you can extrapolate this to the whole hospital, as Alexander showed, it's a possibility of huge cost savings across the hospital. And one of the issues of hospitals is that they are so departmentalized, as was also mentioned before, that these issues are hardly ever seen because everyone has their own small stock, which is always a little bit too big. And if you pull it together and are able to quickly find it using the RTLS, that's a much better way to go. Also, what we saw is that including data from Wi-Fi, which is far more available than the infrared system that we put in this specific department. If you combine those two types of data, you will get an even better system. So in the future, we have to make a sort of a hybrid system from that. So I already mentioned hospitals are dynamic environments, so please take care of that and use it in your project and be aware of it. And what we also saw was that we did an initial training for the staff, and then we followed up that training. But even with follow-up training, people still forget their badge, still forget how the system works, they forget their login codes. All these things we have to keep reminding them so that it stays top of mind. So what we also saw was that although the utilization, as Alex mentioned, is calculated by everything that is in storage or then is not in storage, this is still an approximation of reality because we can't actually see which devices are in use or are not in use. So to improve this proxy, what we could do in the future is use data from other sources as well and incorporate that in the RTLS system. For instance, there are several devices that have their own Wi-Fi system on board, which relays information about its use. And if we integrate that into our system, it will be even better. So that finalizes our talk, and I would want to encourage you to visit us in our booth, booth 11, during the session later. Thanks for your attention.
That's great. So, if I understand it correctly, the system tells you whether or not an asset is being used, but could it also in the future tell us how well it's being used?
Potentially, yes.
Or you're using the right thing for the
Yes.
right application?
Yeah.
And what about, for instance, in a natural disaster? So, we have a temporary hospital at a site. Could this thinking also be applied there to understand the dynamics of those kinds of temporary hospital setups?
I think we only just started with the concept of efficient workflows, etc.
Right.
Stuff in the hospital is being done for so long already that people forgot why they started doing it in the first place, or some issues in the workflow are so common that no one actually notices them anymore.
Yeah.
So also the stopwatch method that we used, you
Yeah.
could use it basically on every process, like sitting behind a computer and doing some input work, for instance.
Sure.
Of course, the computer could also register it, but it's much easier if it's a specific task to record it using an external device. But integrating those data could also give new insights. Yeah.
And let me ask you maybe potentially a crazy question, but given this kind of insight and the cost reduction is significant, which is great, and we know in healthcare we need that. But I think of around the corner, I can get a moped on demand. It's sitting on the street, and I just put my card on it and I take it and go, right? Could this model potentially lead us to a future around, basically, assets being paid for, used based on their usage and easily demand?
Possibly, yeah.
Possibly, yeah. I think within a hospital with internal accounting, this could help a lot, exactly with the same sort of model that you just described, by a sort of pay-per-use model to, in the end, make usage of these assets as efficient as possible. Like Job described, right now it's a sort of stockpiling method where every department stockpiles, and it would avoid that, yeah.
So speaking of stockpiling, then we can't help but mention, of course, during the latest pandemic, the issue of ventilators and oxygen-related items. In that case, the whole paradigm and whole model was completely thrown out the window, right? I mean, nobody experienced it before in the last, say, 80 years. What's your advice on that situation, given your system? How do you play that into the whole algorithm?
Yeah, I think what I mentioned before, so at least understanding potential workflow of if you create a temporary hospital, for instance,
Yeah.
You could use the insights that we gathered from this pilot, combined with, for instance, pilot 9 as well, and also pilot 10. I think if we integrate all those insights and sort of simulate the future of the future hospital, that might actually be very beneficial. And also, what we saw is that we created hospitals, and then a few weeks later, they were not necessary anymore.
Right.
So perhaps it would also been an option to have smaller capacity, but then spread it out, and then you would have used resources more efficiently.
Okay. Great. Thank you, gentlemen. That was amazing. We'll again have a short break, and we'll be back for the final pilot.